Here we have to take the derivative of this natural log function. And you'll notice this is a composed function. It's not just simply the natural log of x, for example. We've got the natural log of this function of x, quotient x cubed minus 12 over x. So we'll use the chain rule to get this done. And with the chain rule, you're taking the derivative of a composed function. So we'll write this up using the letter u. So first thing that's going on is we're taking the natural log of something, and I'll call that something u. And u is a statement of x, which is that quotient x cubed minus 12 over x. The chain rule says that I can get the derivative of y with respect to x if I first take the derivative of that outside component, which is here the derivative of y with respect to u, and then multiply by the derivative of that inside component, which is the derivative of u with respect to x. And the product of these two things will chain out that du piece and give us the derivative of y, which is our function with respect to x. So we'll start by getting the derivative of y with respect to u. So when you want to take the derivative of a natural log, assuming you're taking the derivative with respect to the variable that's there, in this case u, you just take the reciprocal or put it under 1. So the derivative of ln u with respect to u is 1 over u. The derivative of u with respect to x is the other piece we need, and that's that quotient on the inside. Now we could use the quotient rule to find that derivative, but it may be more convenient since the denominator of that quotient is a single term to just divide each of the terms above individually. So u can be written as x cubed divided by x is x squared, and then 12 divided by x is either 12 over x, or let's write it as 12x to the negative 1. And writing it that way, we can use the power rule. We'll bring the 2 down, multiply the x. We'll bring the negative 1 down, gives us a positive 12. And then we could write this as x to the negative 2, or let's put it as x squared on the bottom, since it might be effective to get this as a single term. We'll see that when we finish evaluating this chain rule form. So now we've got to multiply these two statements together, dy by du times du by dx. Now, there is no u in the problem. We just introduced that u to facilitate getting the derivative. But we don't want to answer in terms of u. So even though dy by du is 1 over u, we should consider the fact that u is really a statement of x. So if we were to divide by u, and u is a fraction, right? 1 divided by u, 1 divided by this fraction. When you divide by a fraction, you can alternatively multiply by its reciprocal. So 1 over u is really just the reciprocal of u. So we can write this 1 over u as x on top and x cubed minus 12 on bottom. And we can fill that in here. This is our dy by du as part of our derivative here in the chain rule. So next we got to multiply by du dx. And it may work to just simply write these side by side. You can put this in parentheses. But if we can get du dx written as a single term, there's likely going to be a factor of x that'll cancel in this case. So let's write this up using a single term. We'll get a common denominator between the two terms here. So, of course, there's a 1 underneath this 2x. You can think of it that way. So the common denominator between these two terms is x squared. So 12 is already over x squared. So if I was to write 2x over x squared, I would need to multiply top and bottom by x squared. So this first term, if I did 2x, if I multiply it by x squared, I end up with 2x cubed. And now both terms are over x squared, so we can write them as a single term here, like that. And this is our du dx, which will multiply with our dy du over here in order to get dy by dx, which is what we need. So du dx again is 2x cubed plus 12 over x squared. And then we'll look for common factors to cancel. So you might notice here there's a factor of x. This x will cancel with one of the two factors of x we have over in this factor. So get rid of that, mess that up a little bit. There we go, x squared. So we'll cancel off one of those factors. There's a common factor of 2 here, but there's really no sense in pulling it out because there is no 2 down below to cancel with. So we can just multiply these two quotients together. We've got 2x cubed on top plus 12. And then we've got the x cubed minus 12 times a single factor of x. So that'll give us x cubed times x is x to the 4th minus 12 times x is 12x. And this here, this quotient is the derivative of y with respect to x, which is what we need. They didn't call it y, they called it f of x, but same difference. So this should be the derivative. Hopefully that's helpful. Thanks. Bye.